Hello everyone, welcome back to another STEM Helps video. Before we were talking about how we have, again, I've been writing these graphs repeatedly. If we have a function of, here, let's change this up. If we have a function of position, we talked about how we can use an equation. How about we can use intuition, like when we're driving a car, let's say with velocity. If we have velocity, we can find the change in velocity to find the acceleration, as well as using the method of the introduction to calculus to finding the instantaneous velocity or instantaneous acceleration. But what happens if we wanted to go backwards? Let me finish the acceleration of this. So let's say if we wanted to go backwards, and this is going to be acceleration. Actually, yeah, okay, this is fine. So we have the position graph. I'm starting at, this is of course not realistic. So let me just change this up and make this 0. Let's make this the place where I'm at 0. So at least it's more realistic. So let's say I start at 0, right? And I go forward, and I'm slowly keep going forward, and I stop for some time, and then I go backwards, and I'm back in the same position, right? So I'm going up in position, and then going back down in position, and this is t for time in seconds. So let's wonder, how would we know that when we have the change of velocity, or essentially finding the slope of velocity, we get to acceleration, right? So if we go this way, we find using the slope, and same for this. But how do we go backwards? And so we talked about units, which kind of made intuitive sense, right? If we take meters and divide by seconds, right? Change in time, change position over change in time, we get meters per second, which makes sense. And then we divide that by seconds, we get acceleration. But how do we go back? So let's enlarge this velocity graph, because it makes more sense. It's very easy to digest. So let's have this velocity graph, and we're trying to get to velocity graph with respect to time, and we have this downward line. And let's say this is going to be 2 seconds, and the velocity is going to be, let's say, 1, 2, 3, 4, 5, 6. So this is 6 meters per second, right? 6 meters per second. So how would we go? Let's say I want to find the position at t equals 2. Well, it's implied that you want from 0 to 2, and I'll explain why that happens, because you can't really say, let's say if this makes sense. If I'm a person, right? If let me draw a better stick figure. If I'm a person, right? I'm just walking. If I'm running at 4 meters per second, and you don't know where I'm going, and I'm decreasing. If I say at time 2, where's my position? That doesn't make sense, because we don't have a point of reference, right? So we use 0 as our point of reference. If I say, oh, I'm just walking around. If I say instead, I start from 0 all the way to 5, and it took me 5 seconds to get there, then you could say the velocity at time 5. But it doesn't make sense if I give you velocity at, and if this so happens to be 1 meters per second, if I say I'm going 1 meters per second, what is my position? It doesn't make sense. You need more information. So let's say we have, okay, fine. Let's say in our scenario, Sid, you're crazy from 0 to 2. Now what? How do we get there? Well, using, uh, of course, we can't use intuition because this doesn't intuitively make sense, but we'll try and make this up with units. So we have velocity here, v equals mass, or not mass, meters, sorry, I misspoke, meters divided by seconds, and we want to get to x, which is seconds. So what do we multiply? Sorry, we don't want to get seconds, we want to get meters, I'm sorry. We want to get meters. We want to get meters. God, meters. So what do we do? Well, we can only multiply by seconds. So how do we do that? Well, it's right here. So if velocity is going to be meters per second, we have it in meters per second. And we have the time graph here. And we want from 0 all the way to 2. Well, this is just an area problem. This is basically saying that you need to find the area from 0 to 2. Well, why don't I just go all the way up like this? Why don't I just take the area all the way up like this? And of course, this was a pretty bad sketch, but the reason being that then you could have an infinite position, which doesn't make sense. At time at position 2, you don't have an infinite. Because if you keep coloring it in like this all the way up, you would have an infinite area. That means you would have an infinite position. So it's also bound by this line. So when we take from 0 to 2, and we're saying 0 to 2 because of no information, and we're multiplying by meters per second times t, which is in seconds, because that's how we get to meters, that's how we want to eventually get to position, we find the area under this triangle over here. Let me finish this triangle over here. So in this representation, of course, I need to do better on my coloring skills. If we try and solve this equation, we have meters per second. How much meters per second? Let's see, 1, 2, 3, 4, 5, 6. So 6 meters per second times 2 seconds. There's a bit of a problem here. Pause the video and see if I just left it like this, what would be the problem? Alright, welcome back. So we're basically saying this is going to be the height times this is going to be the base area. Well, what does this sound like? This sounds exactly like a rectangle if we were to graph like a rectangle. So because this is a triangle, we need to multiply this by 1/2, right? By 1/2. And here, let me make this in the numerator. 6 times 2 is 12. And of course you can cancel this out, but I want to show you that this is all review. This is 2 seconds. So the units cancel out. So 6 meters times 2 times 1/2 would just be 12 over 2 meters, which is equal to 6 meters. So it's saying from velocity 0 to 2, we have a position of 6 meters. And it doesn't seem intuitive if we just have this graph and we just say, oh, okay, the time is 2, it's just 0, right? We just have the point of 0. Well, that says the velocity is 0. So it's not a very intuitive approach, but using the units, it should make more sense to you, and we'll have more problems like this. And I hope that's helpful.